Okay, let's talk rules of exponents. So before we really get into doing examples, I want to just point out something kind of quick, right? So we've got four basic operations. We've got adding, subtracting, multiplying, and dividing. Well, if you're anything like me, back in the day when you learned all of these initially, you're like, I like to add and I like to multiply. To me, those were just easier. They made more sense. Then we got into subtracting and dividing, and they were more difficult. So here's the thing. Keep that in mind. Adding and multiplying go together. Subtracting and dividing go together. And I'm going to show you why this works. So first, let's start with a multiplication. And we're going to use numbers. No, we're going to use variables. I just think it's easier. We have some number x raised to the second power, and we're going to multiply that by some number x raised to the fourth power. Now first, remember what exponents mean, right? Exponents are repeated multiplication. So if I have 2 squared, that's the same as 2 times 2, right? So 2 squared equals 4. Okay, so because that's true, ooh, where's my pointer? I don't know where this line came from. Ignore it. Okay, so because that's true, x squared is the same as x times x, right? Because it's repeated multiplication. It's an x 2 times. Now, x to the fourth would be an x 4 times, right? That's what this means. So if I do that, I have 1, 2, 3, 4, 5, 6 x's. This right here is the same as x raised to the 6th power. Now, how does that relate to our initial question? Well, 2 plus 4 is 6. So if I multiply with the same base meaning the x's, right, the piece that has the exponent is the same. If I multiply with the same base, we add the exponents. Okay, that's the first rule. When I multiply, same base, I add the exponent. 2 plus 4 gave me the 6. Now, this works similarly with division. So if I would have x to the 8th over x to the 3rd. Now, think about what x to the 8th means. It means I have an x 8 times. I should have picked a smaller number. Okay, 8 of them. X to the 3rd means I have an x 3 times. Well, if you are dividing and you have this similar factors, same factors, numerator, denominator, you can reduce those. So like this x can cancel out, this x can cancel out, this x can cancel out. I am left with 1, 2, 3, 4, 5. So this is the same as x to the 5th. Now, see how that relates to our initial question. Well, 8 minus 3 is 5. So, right? If I am dividing with the same base, again, the base is the piece that has the exponent. So the x here is the base. If I'm dividing with the same base, I subtract the exponents. And I always subtract numerator minus denominator. So 8 minus 3. So the answer there, again, is x to the 5th. Now, the last one I'm going to get into in this first video is what we call a power to a power. So if I want to stick with my base x, if I have x to the 2nd, and I'm going to raise that to the 3rd power. So we call this a power to a power because we have an exponent reach to another exponent. Okay, so now in doing that, what does this mean? Remember, an exponent, this 3, means I'm going to take whatever is inside the parentheses and I'm going to do it 3 times. So this is the same as x squared times x squared times x squared, right? 3 times I take what's inside. Now go back to what we just did. That's x times x times x times x times x times x. 1, 2, 3, 4, 5, 6 x's. So this is the same as x to the 6th. How does that relate to our initial problem? Well, 2 times 3 is 6. So if I have a power raised to a power, right, power to a power, we multiply the exponents. Okay, so I'm going to do 3 quick examples just to show this, right? So first example, I'm going to take y to the 8th times y to the 4th. I multiply, same base, so I add. 8 plus 4, my answer is y to the 12th. If I divide, let's do m to the 12th divided by m to the 7th. I'm dividing, same base, so I subtract. 12 minus 7 gives me m to the 5th. And my third example, if I take t to the 8th power and I raise it to the 7th power. This is a power to a power, so I multiply my exponents and I get t to the 56th. And that is a quick run through of 3 exponential rules.